And welcome back to the A4Q Testing Summit. We're live with you from Zürich, Switzerland, and today with me I have Nirmala. She is the Secretary of the MSTQB, and she plays a very big role in growing and connecting the software testing community in Mauritius. Nirmala, please tell me more about how you can start a career in software testing.
Hi, Debbie. Thank you very much. So that's the topic that we are going to cover today. I wanted to start with a little story about how I started in testing. That was in the 2006. Just finished university, and I didn't know what I wanted to do. Didn't know anything about the IT community and what different paths there were in the career of IT. And then I was uh, interning at a local company, and I was helping to create user guides during that time. And I knew my internship was coming to an end, so I started applying at all different companies, and I did get some replies. And then I was asked to do an interview at a company, and I went for a Java developer role. They asked me, "Are you really good at Java?" I said, "Not really. I need to learn now." And they gave me a written test. I did the test, most likely bombed it. I don't know. I don't know the results till today, but most likely bombed it. And during the interview, the guy who was doing the interview, he was English, and he asked me, "What are you currently doing?" So I said, "Look, I'm working on writing user guides for this company." And he said, "Do you enjoy it?" I said, "Yes." And he started asking, "Would you be interested in doing testing?" I don't know anything about testing, never heard about testing at that time. And then I said, "Okay, yeah, sure, why not?" I was just looking for a job, I just finished university. So I said, "Yeah, sure, why not? I can do that." That's how I started in testing. But it was really a coincidence. It was really chance. It was really uh, out of the blue. But today's talk is really to educate youngsters who want to start a career in IT on how they can start it, what it means, what it entails, and why do we need testing as well. So, yeah, that was a quick story about me, but yeah, that's why I chose this topic because it can be really helpful for young people starting their careers or others who are thinking about changing their careers in and going into testing. Yeah.
I think
So
I think many young individuals struggle with deciding a career path,
mhm,
especially after their studies. I'm
yeah.
looking forward to your insightful presentation. I'd just like to ask the audience to keep in mind that tune in, leave comments if you have any questions, and we will answer them towards the end of the Q&A session. Over to you, Namala.
Thank you. All right, so let's start with the presentation. So I told you a bit about who am I, how I started in testing. So I started in 2006 with that little story, which was a coincidence, and then I learned a lot about testing from my mentors at that company. They showed me everything there is to know about testing uh, when I was there. Right, so I wanted to share that experience with you guys. Today, I'm the test manager at Ikera, which is a French company, and I'm based in Mauritius. So I manage a team of testers. We have manual automation, etc., that we do. And as Abby said, I am the secretary of MSTQB. So, what is MSTQB? I'm sure you've all heard about ISTQB, which is the International Software Testing Qualification Board. So MSTQB is the Mauritian chapter of that board. So we represent ISTQB in Mauritius. So let's start a bit about what is testing. So we do testing in everyday life. We test when we are cooking our food. We test when we are buying something new. We will just verify whether it's what we are looking for, whether it fits us, whether it looks nice on us. All of that is testing. Testing is not just about software testing, but even when you buy a house, for example, or you're building a house, you will look at the plan. You will see whether it meets your requirements. That's also testing. Okay, so let's see the definition of testing, right? So testing is defined as a practice of making objective judgment regarding the extent to which an entity meets, exceeds, or fails to meet defined objectives. So it's all about having defined objectives. So it could be quality characteristics like does it fit what you want to do with it? Does it look good? Is it easy to use? Or it could be other characteristics like does it perform as you expect it to perform? Or if it's a house, is it big enough for your family? So these are defined objectives. So testing is just about making sure whether you're either meeting those objectives that you've set or you're exceeding them. I think that's the best thing we can have, or you fail to meet them. And if you fail to meet them, what do you do to bring it back to it meeting your objectives, right? So that's about testing. So what's software testing? Well, today we are surrounded by software. We have software in our watches, we have software in our cars, we have software in our homes, even our lights are turned on and off with software. So there, software is really everywhere. We need to do software testing to make sure that we are meeting, exceeding, or failing to meet objectives for those software. So ISTQB defines software testing as examination of artifacts and behavior of software systems to check conformance to a set of predefined requirements. Okay, so it's predefined requirements. It could be around the functionality. Is it doing what I need it to do? It could be around non-functional aspects. Is it easy to use? Is it giving me the response I need quick enough or not quick enough? So these are all requirements, and it's not just about making sure it's doing what you want it to do. So it's bigger than that. And software testing, we tend to believe that software testing is just about having your program, executing your program, and then saying it's working or not. But testing is much larger than that. You don't just test the code. You test also the requirements. So when your clients are telling you what they need, are are they correct? Are they testable? Are they easy enough to understand? Are there any assumptions that you're making? So these are all ways of doing testing. So why should we test? Right. So I've mentioned a few types of things that we can test, but why should you test? Like I said, when you're buying clothes, for example, you try it on. You see whether the color matches you, whether you are comfortable in it, whether it's a good fit or not. So you're making sure that when you're going to wear that cloth, it's going to be good, right? So why do we need to test? If we don't test or we don't test enough, it can lead to I'll give you some example. It's not an exhaustive list, but it's some example. So it can lead to embarrassment, loss of reputation, or even contracts. Okay, so I've got a small video showing the blue screen of death. That's a story maybe most of you have already seen or heard about, is at the launch of Windows 98. So I'll let you
Plug it in.
just view.
It's going to say, hey, I see you plugged in a new device. And it's going to load in the appropriate drivers. You'll notice that this scanner build, whoa. Moving right along.
That must be why we're not shipping Windows 98 yet.
Absolutely. Absolutely.
Right. So you saw in this video, so you have Bill Gates and Chris Capocella, who was his CIO at that time, on stage. They are presenting their Windows 98, and they are trying to say that you can plug and play any device. And the moment they plugged the device, blue screen of death, and the application crash. Yeah, well, if you look at their faces, they are very embarrassed. And from what I've read, they lost quite a few contracts on that day. Yeah, so just an example of how it can be embarrassing when you don't test enough. So an issue in probably they did not verify when they do the plug and play, will it really play? Probably they checked the device on its own, they checked Windows on its own, and then they didn't really verify whether all the time when you're plugging the device, it's going to play. So it's maybe not being tested enough, but it can lead to quite an embarrassing situation for people. Right? It can also lead to angry customers, right? Your customers are not happy when they have issues. Most of you probably have encountered situations where you're using a software, but it's not working as you expected it to work, and you were angry. So we'll see an example of the Terminal 5 at Heathrow. It was opened in 2008.
Dozens of flights have been cancelled as delays, broken lifts, lost baggage and a protest made the first full day of operations at Heathrow's new Terminal 5 an eventful one. The $8.6 billion terminal, built to manage 30 million passengers a year, is meant to handle 12,000 bags an hour with state-of-the-art technology. But the system broke down somewhere inside what is now Britain's largest enclosed space.
Come up from San Francisco and there's no baggage. We're standing there for over half an hour. Systems are down. It's a right mess.
Well, pretty awful really, because we landed from LA at 9:30 and it's now 11:15. So not too happy about that.
One hassle passengers avoided.
Right, so as you can see, the customers are not happy. So this was promoted as having the biggest, largest, best baggage handling system. So it was a new system that they were putting in place, and it worked during their testing, because when you're testing, most of the time you're not thinking about the volume that you're going to operate. And then when they started getting loads and loads of flights coming in at the same time, they ended up having a breakdown of the system for the baggage handling. So there were passengers who had to take flights only with their carry-on. Their baggage remained at Heathrow, and there were some who came, as you saw in the video, they came, their baggage was still not delivered 2 hours afterwards. So they were not happy at all, as you can see in the video. And then the next one is, in extreme cases, it can even lead to loss of life. And these can be seen in medical or in aviation. So I've got an example of a machine that was created to treat cancer patients. It's explaining what went wrong. So as you can see in the well, it goes a bit fast, but what happened was, this was the first machine that they started selling, which was controlling everything by computer. And there was a bug that happened only in specific cases. So if you made a change and within 8 seconds you operated the machine, it was causing the radiation to be very high. And they did not catch this because it was really in extreme conditions that it was happening. And it led to 4 patients being killed and 2 more being seriously injured with lifelong consequences. So it was just a malfunction of part of the system, which was the software operating the machine, that caused death. Yeah, so that's another example. And then it can be very, very expensive for organizations when you leave defects and they go on production. Okay, for example, probably you've heard about this one, is a Y2K bug. It happened in the year 2000. So in 1999, they started thinking, my computer system does not know how to handle centuries. Yeah, it was all about two-digit years that they were handling at that moment, because people had not anticipated enough that in 2000 the year was going to change. So 01 would still be seen as 19001 instead of 20001. So that cost around $500 billion to fix. The cost was to banks, to transport, to government. A lot of people had to bear the cost for that bug. And then Pentium had an issue where the hardware was not working as expected. They had to recall the hardware because there was a programming error in there, and that cost Pentium around $475 million. And I think this one is a very famous one, where the Mars orbiter exploded in the air. So what happened in there? It was developed by a multinational team. So there were some team members who were working in the metric, so millimeters, meters, etc. And there were some team members who were working with a British system, so inches, feet, pounds. So what they did was, for a calculation, one team programmed it as millimeter, the other read it as inches. So that made a clash in the measurement, which caused Mars orbiter to crash. If there had been enough testing around that, they probably would have found it already. And it cost NASA $193 million. And then this one also, probably you've heard about it, where Toyota had to recall the Lexus in 2009. That also happened due to a software error where under certain conditions, when you press the brake, instead of braking, the car was accelerating. So that this led to accidents, and I think one person died as well. So they decided to recall all the Lexus in that year, and it cost Toyota $3 billion, which is, as you can see, quite large sums of money. And if you go on the internet, you try to look at expensive bugs, you will find that there are much more examples where defects cost money to businesses. Okay, so those are some of the reasons why we need to test, and we need to test well. Uh, Now you are starting to hear about testing, you're starting to hear about early testing, shift left approach, etc. So I thought it was important to show you how much it can cost to correct an issue, depending on where it happens. So when you are finding an issue at the design or requirement phase, you probably only have to read through the requirement, find the defect, correct it immediately. So you don't have a code that's already been developed, a code that's already been tested. It's just a document. So you find the defect directly and you fix it directly. So the cost is really, really low. And if you find a defect during implementation, so when the developer is already working on it and doing their unit test, or when they are developing itself, they find the defect, they are already in the code, they are still there, they're still working on that. So they fix it quite quickly. So it's about 6.5 times more costly to fix than in design. But then when you come to testing, it's about 2 times more than during implementation. So when your developers have already developed the code, they've sent it to you for testing, you are testing, so effort has been spent in testing the application. You find a defect, what you have to do, for you to raise a defect, you have to ensure that it's really a defect. So time is spent, effort is spent making sure it's a defect on the testing side. Then you raise a defect in your whatever defect management system you're working on, and then it goes to the developer. They have to debug, they have to find what is causing the issue, fix the issue, test it at their side, make sure it's working, and then redeploy it to your environment for you to test it at your end. You have to make sure that the fix is working, but you have to also make sure that the application has not been adversely impacted. So you're doing confirmation and regression testing for that defect. So the cost is twice as much as if you found it at the development level. And then when it's already in production, so your users are already using it, firstly, we'll have all the impacts that we just saw because it's out there, people are seeing it, your users are seeing it, so that's an impact. But also, it's already gone through development, testing, gone on production, and then they're finding it. So it goes back to your application support team, they have to analyze it, probably to your test team, they have to reproduce the issue, raise the defect, and then it goes to your developers. They will analyze, they will debug. Sometimes it's really complex to reproduce that issue or to find what has caused that issue. So it can be up to 100 times more costly to fix a defect when it's already on the on your production side. Why I'm showing you this image is just to make you understand that testing is really important, and testing early in your software development lifecycle, that's more important as well, right? So we've seen what is testing, why we need to test, importance of early testing. So what are the different types of tests that we can do? Okay, so as I was saying earlier, we can test uh, the requirement, we can test the design, we can test the code without executing the code, right? So all of this, when you are not executing the code, it's called static testing. Okay, so you're not executing something to find whether it's correct or not, right? So what you're looking for here is whether it's easy to understand, whether it's easy to implement, whether it's easy to test, whether there are things that are not in agreement to what has been said, whether there are some requirements that are contradicting others. So you're looking into those things if you're looking at requirement. If you're looking into the code, you're looking into, for example, whether all variables have been declared, whether all declared variables are being used. You can find that without executing the code. Okay, so that's what we call static testing. And then you have dynamic testing, which is the most known, is where we are going to um, run the test. So we are going to use the application against our defined set of objectives to make sure that it's doing what we expect it to do. So that's dynamic testing. Okay, and it need not be just functional. So the next one is it can be functional. So is it doing what it needs to do? Or it could be functional. How is it doing it? How is it behaving when it's performing whatever it needs to perform? Okay, so functional is making sure your user requirements are met functionally, so it's doing what you need it to do. And non-functional is performance testing, for example, accessibility testing, for example. Those are non-functional areas. So is it responding as you expect it to respond? Okay, so functional and non-functional. I've listed down some types of testing as well here. And then we are hearing a lot about automated testing. So what is manual and what is automated? Manual is when you have a person intervening to perform the test. So it's your test team, it's your dev team, it's your product owners, it's your business analyst, whoever who is involved in the SDLC of your project. They are doing it as a person. So that's manual. And then automated, simplest term, you use a software to test the software. So you program a software to run through the test for you and then to verify whether it's doing what it needs to do, right? So that's manual and automated. So these are some types of testing. Okay, so let's start looking into some myths around testing. So during my career, I've encountered a lot of these where when I was doing interviews for some junior team members to join my team, and I asked them, so what's your motivation to join testing? Most of the time they will tell me, I don't like development. It's tougher than testing. That's a myth. It's not tougher. Okay, they each have their own complexity. Testing is not, as we saw, there are different ways you can test. There are different types of testing that you can do. So it's not just going in and playing around on an application and then saying, yeah, it's working or not. It's more complex than that. You have to have an understanding of the business. You have to have an understanding of test techniques. You have to have an understanding of the underlying architecture when you are testing. So it's not easier than development. I don't agree with that. So for me, that's a myth. Software testing engineers are low-paid jobs. That's also something I hear a lot in Mauritius. I'm not sure about international, but in Mauritius we used to hear that a lot. That's completely not true. I do know now that the market has completely evolved, where software engineers are paid as much as developers. So that's completely not true. Testing is only about executing the software to see it works. I think that we've already debunked from the last slide. So it's not just about running through the application, making sure it's working, but there's much more than that involved in testing. Testing is a bottleneck in the STLC. This is often, and still we encounter this, where testing takes a lot of time, and oftentimes you have test teams which are smaller than the development team, so you are always pressed for time when you're testing. And if you find an issue, you're going to block the process just to make sure that they correct it. So it can be seen as a bottleneck, but I prefer looking at testing as a collaboration between developers, testers, product owners, and anyone involved in the SDLC, so that our end goal is the same. Every one of us wants to have a quality product at the end of the day. So we can't be seen as a bottleneck. We work together to ensure that we are giving something of good quality on production. Okay, testing is about criticizing the work of others. Oftentimes you will hear, so what did you break in my code today? Yeah, but testers do not break the code. We just um, run through the code. We go through the application using different conditions than the developers have thought about, and it kind of meets the condition that would show where the defect is. So our job is not criticizing the work of others, it's not breaking the work of others. On the contrary, is to work together with them to help them find issues that probably they've not thought about. So testing is not about criticizing the work of others, even if it can be seen like that. So that's a myth for me. Testing does not require much technical knowledge. That's completely false. As I was saying, you have to understand the architecture behind. You have to understand the design when it's being done. You have to have a good understanding of your database, for example. So you have to have a good, if not good, but at least a working understanding of the code that you're using, right? So you need technical knowledge to be a good tester. And now that we're moving towards agile, team members are T-shaped. So you have to understand development, you have to understand business requirement, you have to understand the whole panoply of jobs that you can have in a squad. But then obviously you master testing, so you have to have technical knowledge, especially in agile. Okay, one cannot make a successful career in testing. There is no innovation evolution in the field of testing. These two are completely false. For the career, I have a slide just after to show you some possible careers that you can have in testing. And there is no evolution and innovation in the field of testing is completely false. If you go on the ISTQB site, you will see that they are always constantly updating their syllabus. If there was no evolution, the syllabus would not need to be evolved, right? So you have AI coming in, you have new techniques coming in for the testing, you have new development processes coming in, you have to adapt your testing to that. So that's completely false. You are always innovating, you are always evolving, even in the testing field. Okay, so for one cannot make a career. So I have a potential career path that you can have as a tester. And we've seen that happen in Mauritius, I'm sure, because we work with international companies. So I'm sure it's probably the same outside of Mauritius as well. So normally someone who just finished their studies, they will start as an associate level. So associate level is like a trainee. And then they move on to software test engineer, to senior, to a lead level. Lead is someone who will look at maybe more than one project at a time. And then your team level, test team leader level, where you start getting responsibilities for people as well. Test manager, so you're working around test strategies, test policies that you have to implement in your organization. You can even become a quality director or a CEO of a company. Nothing stops you becoming a CEO of a company if you are in the testing field. So if I look at myself, I started as a trainee software test engineer, and today I'm a test manager managing a team of around 20 people. So you can grow in the testing field as well. Yeah, but there are also other things that you can do as a tester. You can move to other fields, like you can start specializing in automation. This is something that's really in demand today, I think around the world, but in Mauritius a lot. So you can go into automation, so become a specialist in automation. You can become a specialist in security, in performance. You can even change your career towards product owners. Why? Because you have a good understanding of your business, of what your business is doing. So product owners, they work really in close collaboration with your business users, so you can become a product owner as well. And if you want, you can become a developer as well. That nothing stops you moving towards development as well. Okay, so those are possible career paths that you can have. And then, well, you will ask me, so what do I need to have as skills for me to become a good software test engineer? So firstly, for me, it's communication. Testers are often in the middle of everything. So you are talking to your product owners, you're talking to your developers, you're talking to the stakeholders, you're talking to other testers, you're talking to the automation test team, you're talking to the performance test team. So you're really talking to various people with different mindset. And somewhere you are saying, okay, I found a defect in your code. You can be seen as critiquing someone else. So you have to have good communication skills. Okay. Next one is inquisitiveness, not being afraid of asking questions. If we're not inquisitive as a tester, we will accept assumptions being made. We will accept what others are telling us. And that's complete no-no as a good tester. You have to always challenge others. Okay, so you have to ask questions. You have to have a good analytical mind. So you're analyzing requirements, you're analyzing a design document, for example. So you need to have an analytical mind, always looking for the worst case. This is good or bad. You are always looking at the worst case. And what I've found is, even in life, I'm always looking at the worst case. Yeah, because we are the ones who need to challenge others. So we're always looking at the worst case. Keep in mind the big picture. So why are we doing the changes that we're doing? Why are we implementing the application? Why are we correcting that defect? Always keep in mind why we need what we are programming. Detail oriented. So you have to have the big picture, but you also have to look at the nitty gritty of things. An example that I think I'm a bit running out of time, but just quickly, an example that I used to tell my team members is, if we leave an error of 0.1 cent in one payment, when you have thousands of payment, how much is that going to amount to in total? So every little detail is important. Okay, working under pressure, we are always pressed for time, because even if we're working in a collaborative environment in Agile, you will end up having to do end-to-end tests, regression tests, to make sure everything is working correctly before you go on production. So you will always be pressed for time. And as for any job, always keep an eye on the technical changes going on in the world, and also the different trends that you have in the industry. We are talking a lot about AI today. So what are changing? I think during the summit, there were quite a few talks around AI and using AI in testing. So this is something new that's happening. How is it going to impact the testing field? How is it going to impact what you're doing today in your testing? So for me, these are some of the main characteristics that you need to have as a software test engineer. Well, that brings me to the end of the presentation. If you want to connect with MSTQB, We are on Facebook, LinkedIn, and on YouTube as well. And you can email us at any time at info@mstqb.mu. And now I'm open to questions if there are any. If you are shy asking the question now, please leave it in the comments on whatever channel you're looking, and also we can reply to it afterwards as well. Not a problem. So that's it from me, Abby. Do we have any
Thank you
questions?
so much. That was such a wonderful presentation. We have one question so far. What is the most important quality that a software tester should have?
Yeah, so we were looking at it just before, some of the important characteristics that we need. So for me, well, in a Mauritian context, what I think we need to have is not being afraid of asking questions. This is really key because we are looking at requirements, we are looking at the code, we are looking at talking to the stakeholders. So if we are afraid of asking questions, we will not be able to challenge them. So for me, that's the most important quality that a software tester should have.
Definitely. And you mentioning communication, I think that's also definitely a very
Yeah.
big quality. Our next question, what do you enjoy most in your software testing career?
Uh, well, I started as a trainee. Today I'm a manager. So when I was really into the job of testing, it was really understanding everything that's going around. So I was asking questions to the developers, to the technical architects, to the DBAs. I really needed to know everything that's going around in my project, and that was something that I really enjoyed. And I was when I was leaving a company, someone said, "Oh, Nyamala is going. She's the oracle. She knows everything that we need to know about this company. So what's going to happen to us?" Yeah. So I love that. I love that aspect of really understanding the business and knowing what's going on in the application, going on behind the scene in the application. That's the most enjoyable thing for me during my career.
Definitely. We have one more question. Can
Sure.
anyone have a career in testing, even if they don't have a degree in an IT field?
Definitely, you can, as long as you have the qualities required. I think you can be a tester. Even when I started, my mentor, she did not have a degree in IT. She was someone from a mathematical background, and she was one of the best testers I've known. She taught me everything I knew today. So for someone to do well in software testing, they need to be inquisitive. They need to ask questions. They need to know how to read a requirement, etc. And they need to be good communicators. So it's not primordial to have a degree in IT. Of course, it's good because you will have an understanding of the technical aspects of things. But if you don't have it and you want to have a career in testing, it's not a problem. And then you have lots of certifications around, like ISTQB provides, where you can do it and get the base of what you need as a software tester as well. Yeah. So for me, yeah.
Wonderful. Yeah, thank you so much. I'd like to just encourage our viewers today to go to our website, click on our program. On Nirmala's session, you can go ahead and vote for her. We will be having a best presentation and best speaker this year. So please don't hesitate to go and vote for this presentation. We will be collecting the votes and making an announcement later on. Thank you again, Nirmala, for such an insightful presentation. And I think the youth of today would find a lot of valuable information about taking testing as a career.
I hope so.
Yeah, definitely. Stay tuned, audience. We will be back again on the hour, every hour. And thank you again.
Thank you. Thank you, everyone. Have a good day.